Hello, in this video we will examine how students can use various ClassWiz features to support their understanding of functions, especially linear and quadratic functions. So turn on your ClassWiz and let's set it up. We will firstly be using Calculate mode in this video, so select the menu and number 1 for Calculate mode. Now the basic idea of a function is that it describes a relationship between two sets of numbers. The critical feature is that every input number is associated with exactly one output number. A good way to see this on ClassWiz is to use the calc facility to make a function machine. The relationship is described symbolically and the ClassWiz lets you generate values. For example, a function for which the first value is represented by d and the second value by 1 more than 4 times d is shown on the screen here. F at d is 4 times d add 1. So that's how it's represented in everyday life. On the calculator, we enter 4d add 1 using 4 is okay. The d, we have to use the alpha key and then sign. The sign key, you notice a small d in pink letters above the sign key, 4d, and add 1. So that's the expression on the right-hand side of the function, 4 times the value, add 1. Don't tap the equals key. Instead of tapping the equals key, what we'll do is tap the calc key, which is up here next to the option key. And when you tap the calc key, as I've just done, you can see the present value of d is shown. So to find the value of the function, when d has that value, the moment that you can see the value is shown as 4, you simply need to press the equals key and the value is 17. 4 times 4 add 1 is equal to 17. If we wanted to find the value of the function for a different value of d, tap the equals key again and change the value. Let's change the value from presently it's showing 4, let's make it 5. And tap the equals key again. You can see the value of d is set now to 5. And the value of the function is 21. We could tap the equals again to show the value of the function when we've got d is 13. And we can see 4 times 13 add 1 is 53. So you can continue this process for as long as you like. Each value of d generates exactly one value for f at d, as is required for a function. We can also use negative values for d, of course, using the correct negative key, negative 5, for example. The result when d is negative 5 is 4 times negative 5 is negative 20, add 1 is negative 19. Now ClassWiz allows various symbols to be used, mostly shown in pink letters on the keyboard, as you can see here, and accessed A, B, C, D, E, F, and X and Y and M, accessed with the alpha key up here. You can also use the X key, which is over here, which is convenient as it does not require the alpha key to be used first. It's helpful for students to see that the choice of variable does not matter, so that the function f at x is 4x add 1 is the same function as f at d is 4d add 1. So whether we use d or x for the symbol, we'll get the same result. So let's see how that works. Put in 4x, add 1, and we'll use the similar values as we did before. Tap the calc key, and if x has a value of 3, tap equals, and the value is 13, and the same was true when d had the value of 3. So the two functions work in the same way. Now it's a good idea for students to draw graphs of functions, and a function machine like this can help them to generate suitable ordered pairs to do so. However, a more efficient process involves using a table of values. And to see how to do that, we'll shift to table mode. On the ClassWiz, tap menu. Table mode is down as number 9, or you can just tap menu and 9. You don't need to scroll down. Here we see table mode, And we're going to start with a linear function such as f at x is 3x subtract 1. Enter the function definition, which can only have x as the variable. We can't use d and a and b, it must only be x for the class whiz. Once we've entered the function like this, tap the equals key to complete entering the function. We could use alpha and x down here, but of course it's less efficient to do that as it requires you using two keys rather than one key. This time we're only considering one function. We'll consider two functions later. So we won't enter a function for g, we'll just tap equals. And now we need to choose the values of x for the function. That is the domain of the function. Class whiz allows a sequence of up to 30 values to be chosen. So in this case, let's choose the values between the integers from 0 to 20. So we'll start with 0. The cursor's up here in the start area, and tap equals. The end value is 20, and we tap equals, and the step is 1, going up in steps of 1, 0, 1, 2, etc. Tap equals, and here we have our table. And you can scroll the table and move the cursor. We can see here on the right hand side I'm moving the values of the function change, and we can move between the columns with the cursor keys as well and see the value of the variable changing. If students look at a table like this, it's quite clear that for this function the values of the function change by 3 every time x goes up by 1. 2 to 5 is 3, 5 to 8 is 3, 8 to 11 is another 3. And of course you can scroll past the bottom of the table down here, or you can go up past the top of the table and get to the bottom. So you can scroll in both directions. And you can look at other values of the function by changing the table settings. So we could, to do that, tap the clear key, AC, and leave the function in. Just tap equals to have the same function. Tap equals again because we don't want a function for g, and we can change the values on the table directly. We might start, for example, with 30 and finish with 50, again going up in steps of 1, and there's our table settings. When we tap equals, we'll have the table. And once again, for this function, the values go up in 3s. 89 to 92 to 95 to 98. As x goes up by 1, the values of the function goes up by 3. If the x values increased in a different way, then the function values would increase differently too. For example, if the x values went up in steps of 2, let's see how that works. Tap clear, equals and equals. Let's start, say, start with negative 10 and go up to values of 30, but this time go up in steps of 2, not in steps of 1. So the table will look different, and tap equals to see the table. Now the change is not negative, not going up by 3, it's going by 6 each time, 5, 11, 17, etc. So once the table is displayed, you can change the individual x values to see the corresponding value of a table. So if students wanted to know, for example, what's the value of the function when x is equal to 11, I'm highlighted another value, I'm simply changing it to 11, and the value of the function is 32 in this particular case. And we can change any of these values in any way that we like, so we could change the 2 to change it to, say, 3, and the value of the function changes accordingly. So that's a very handy facility for students to explore this function in whatever way they like. So the table makes it clear how this function behaves. Values increase steadily by 3 for every single increase in x. The students could use a table like this to sketch a suitable graph on graph paper, and that's an important thing to do. and they could see and understand the gradient of this. And I'll show you a graph here, not on graph paper but drawn on a Casio calculator. You can see that the changes of the function are such that it's going up in a straight line, and the gradient of the line is 3 in this particular case. So students can use a ClassWiz to devote their time to plotting the points and seeing the patterns of the points rather than doing the arithmetic to get the values. Of course, and importantly, different linear functions result in different patterns and different graphs. To change a function, first tap the clear key and tap clear again to clear the function and replace it with another one. So I'm going to clear this function by tapping clear and replace it with the function 2x add 1. Or you could, of course, use the delete key instead. And if we want the function values between 0 and 12, 0 and 12, and a good choice, of course, is to change by 1, not by 2, we can see for this function, the students can see the function's going up 2 each time. That's what it means to have a gradient of 2. The values go up by 2 each time. So this particular linear function goes positively. We could change it to a different function like this one, 12 subtract 2x, and just tap equals to get the same values. And here we see the values of the function go down by 2 each time. So the gradient is negative 2 in this case. So the values start at 12, and if we change the function, and I'm going to use the delete key this time to just change the 12 to 25. So we have a different function again. I'm going to tap equals to accept all of those values, and now we see the function is going down by 2, but this time starting at 25 rather than 12. So ClassWiz allows students to explore various linear functions efficiently and to understand the significance and the meaning of the slope and the constant term for linear functions. Students can also examine a pair of functions together to understand their differences. So, for example, consider these two functions. F at x is 3x add 2 and g at x is 3x subtract 1. So clear again, clear, we're going to put in f at x is 3x add 2. You can see there. And this time we'll have a value for g, 3x subtract 1. Previously we just ignored g. And we can put some values for the function in, let's say from 0 to 12, and just accept those. And here's the table of values for this function. So we can see that the first function is going up by 3, 2, 5, 8, 11, and the second function is going up by 3, starting at a different value. This one starts when, this one starts at -1, g at x is 3x subtract 1, and this one starts at 2, f at x is 3x add 2. So the ClassWiz allows students to explore functions in this kind of a way. Both of these functions have the same slope. They both go up by 3 each time. So if the students were to draw a graph of the function, they will see that the graphs are always 3 apart and that the two lines are parallel. And they should do that on a piece of graph paper. Once again, I don't have graph paper here, but you can see on a Casio graphics calculator, the two functions are drawn here. You can see that the values differ by 3 each time. Between here and here is 3, and they have parallel to each other. Just as for linear functions, ClassWiz allows students to explore other functions in detail, tabulating values and examining properties. So let's look at a quadratic function, such as this one. F at x is x squared subtract 2x subtract 3. Still in table mode, tap clear and enter the function. Clear whatever is there, I'll just tap clear. And x squared subtract 2x, subtract 3. If there's any other functions in G, we'll need to delete those because we're not interested in those at the moment, so I'll just tap clear to do that. And we'll choose some values for a table for this quadratic function. Let's say some values that are negative, say from negative 8 down to, or up to 8, and in steps of 1. And we construct the table by tapping the equals key. Now if we explore the tabulated values, it's clear that this quadratic function is different from the linear functions that we saw previously. There's not a steady increase or decrease in value as x increases. So you can see that the change each time is not uniform as it was before. So when x is equal to negative 8, for example, the value of the function is 77. As x increases, the value decreases, right down to negative 4 down here, and then it seems to increase again. So it's very different from a linear function. And we notice along the way there are two values of x for which the function is actually 0. One of them when x is negative 1, and here's another one when x is equal to 3. And if students explore the table, they will see that it seems to be symmetrical. So we see from here, from this point, the values go negative 3, 0, 5, 12, etc. to 21, and in the other direction they do the same but in the opposite direction. All of these observations help to predict what the shape of a graph of this function might be, and also provide many ordered pairs for a graph to be drawn. To help draw the graph, you might like to take a closer look at some of the points. One way is to change an x value manually. So let's look at when x is equal to 1, for example here. We can change the value to make it 0.5. It's a smaller increase, and we might change the next one to make it 1.5, which is a smaller increase as well, and see that in fact those two values are the same. And it looks as if in fact the value in between these, when x is equal to 1, appears to be the minimum value for this function. So these observations will help students see the minimum point appears to be when x is equal to 1, and the minimum value of the function then is negative 4, and can help students to draw a really good graph on a piece of graph paper. Particularly the hard part of drawing the graph near the turning point of the parabola. And I've got a parabola drawn here. You can see the values of the function drawn. Students will of course draw theirs on a piece of graph paper, but we can see the features of the function after we've drawn a graph, and the class quiz has helped the students to find the most important values, in this case the values where the function has a value of 0 and the turning point. Now class quiz also allows students to find roots and turning points for quadratic functions automatically. To see how to do this, tap the menu key, and we're going to choose the equation function part of the class quiz. You can see I've highlighted it there, or we could tap just number A, and we have in this case a quadratic function which is a polynomial function. So tap number 2, and the polynomial function has a degree of 2, so we tap 2 for it to be a quadratic function. So we enter the coefficients followed by the equal sign. So the coefficient of x is 1, the coefficient of x squared is 1, I beg your pardon. The coefficient of the next one is negative 2, and the final value, the coefficient, is negative 3. And so we've entered the function into the class quiz. If we now tap equals, we'll see the two roots of the function. One of them when x is equal to 3, and one of them when x is equal to negative 1. We saw those from the table. The class quiz now is finding them automatically. So again, if students are drawing a graph, it's an easy thing to do. And if we tap equals again, we see the minimum value of the function when x is equal to 1. as the class whiz indicates over here, and the minimum value is actually -4 when x is equal to 1. So we can use the class whiz to find out some important features of a quadratic function using this other mode, in addition to using the class whiz table to explore the values in detail and to draw a graph. And if we now press clear again, we could go back and define a different function, such as, for instance, the function where f at x is equal to, and I'll show you this one here, a different quadratic function, 5 subtract x squared. So students could say, in this case, the value of the first coefficient is -1 because it's subtract x squared. The value of the coefficient of x is 0 because there's no x term here. And the value of the constant, of course, is 5, as you can see. And for this function, the roots of the function are at square root of 5 and negative the square root of 5. So students could actually think about those, visualize them and plot them on the x-axis. And if we go further, the maximum value of the function, it's a maximum value this time, is when x is equal to 0. And the value of the function when x is equal to 0, you could tell from here, should be 5. And indeed, class whiz has found the value for 5. So class whiz is a powerful tool for exploring values of functions and understanding their properties. In this video, we've only used linear and quadratic functions, but of course students can construct values for other kinds of functions as well, and use the class whiz to explore them in similar kinds of ways. You'll find Module 3 of the Learning Mathematics with Class Whiz book contains lots of information about exploring functions in these and other ways. There's detailed explanatory text which can be copied for students as well as teachers, and the module includes some exercises to check efficient class whiz use, some examples of activities to suggest some educationally valuable things for students to do, and some guidance for teachers. You can download this book freely from the Casio Worldwide Education website. Happy calculating!